Hello guys. In this video, I would like to present three nonlinear systems with complete solutions. These three systems are not easy, so please pay attention to the details. And also you will find at the end of the video, two practice questions with answers only, where you can practice and learn more. Please note that there is another video with nonlinear systems, part 1, because this is part 2. In part 1, you can find, if you have time, you can go there and check. There are nice, challenging systems. Just to mention also here that what is a nonlinear system? Quickly, we can say a nonlinear system is a system in which at least one equation is not linear. Maybe all of them are not linear, but at least one is not linear. We call the whole system not linear or non-linear, same. No, linear means the power on the x and the power on the y is 1. That's a linear. But the whole system here is not linear because of the squared. Now, just some remarks. We can use substitution method sometimes. We can use elimination method sometimes. And sometimes both will not work. You will see in one example. So we have to think of another way. But in all cases, we must check all the proposed solutions in the original system. Let's start. Question number 1. Look, please, here. Solve the nonlinear system. X plus 3 squared plus y minus 4 squared is equal to 20. And then x plus 4 squared plus y minus 3 squared is equal to 26. Please pause a little here and think, what can we do? These are two circles. Without graphing, we need to find the solution, the points of the intersection, if there is any. What do you think we can do? Well, let me expand each equation and see. In expanding, I have to use these formulas from algebra, perfect square trinomial. So a plus b squared will be a squared plus 2ab plus b squared. A minus b squared is equal to a squared minus 2ab plus b squared. Note here that many students, they forget this middle term. We call it middle term. And always here, plus b squared in both formulas. So I take equation 1. See, from equation 1, I go directly in the expansion form. X squared, 6x plus 9, y squared minus 8y plus 16 is equal to 20. Same thing for equation number 2. Then what can I do? I can multiply equation 1 by minus 1. Directly, I will multiply equation 1 by minus 1 and leave equation 2. Then I will add both equations. So you can see here, minus x squared minus 6x minus 9 minus y squared plus 8y minus 16 is equal minus 20. When you add with equation 2, you get 2x because x squared will be cancelled, y squared will be cancelled. We get 2x plus 7 plus 2y minus 7 is equal to 6. Now, what can we do? What do you think we can do? From this equation, I will get a simple equation that relates x and y. Because the aim here is to make one equation in one variable. To find that variable first, then you come back to the system. So I take the last equation on the second slide. So I can see here, 2x plus 7 plus 2y minus 7 is equal to 6. 7 will cancel out. So I'm left with 2x plus 2y is equal to 6 divided by 2. And then this is the equation that we need. Y equals 3 minus x. I will call it star. You can call it equation 3 or anything you like. So substitute star in equation number 1, which I wrote here for simplicity, just to see it, instead of going back in the slides. So x plus 3 squared, y minus 4 squared is equal to 20. I will replace star directly y there inside the bracket. See, you can see it here in details. X plus 3 squared, 3 minus x, this is the y, minus 4 squared is equal to 20. Now the equation becomes here, x plus 3 squared minus 1 minus x, because 3 minus 4 is minus 1. So we can expand this one again. We can expand this one again. So this one becomes x squared plus 6x plus 9. Here also minus 1, when you square it, you get 1. And then 2 times minus 1 minus x becomes plus 2x, plus x squared equals 20. Simplify the equation, you will get this quadratic. See, this one here, we call it quadratic equation, second degree. There are many ways to solve quadratic. You can factor it. If sometimes you cannot factor, you can use quadratic formula. You can pause a little here to find x. After you find x, what do? You go back to star to find y. So now, from the previous slide, I have x squared plus 4x minus 5 equals 0. I factor it. So x minus 1, x plus 5 is equal to 0. So x will be 1 or x will be minus 5. Directly, I go to star here, waiting. So I put x there, then I put another x there. So I write here, if x is 1, go to star, y will be 2. So 1 and 2. If x is minus 5, go to star, y will be 8. So minus 5 and 8. Now this is not enough. You have to check the proposed solution, which are these two, 1 and 2, minus 5 and 8, in the original system. Check it in both, and they will work. So I can write solution set will be 2 points, 1, 2, minus 5, 8. These are the points of intersection of the two circles. I hope you enjoyed this question. Let's see another one. More difficult question, this one. Question number 2. Please take a few seconds to think at least what can we do here. See, it's already expanded, already simplified. X squared plus 2xy minus y squared is equal to 1. We cannot use elimination here because we cannot eliminate. If we eliminate, let's see, if we eliminate here x squared, we can multiply with minus 1. But look here, we have xy, y squared, and the number. And also, it's not easy to use substitution also. So what can we do? The 0 here will give us a little trick. Okay. So I can factor the second equation here, x plus y, x plus 2y. If you multiply x and x will be x squared, and then 2y, y will be y squared. Inside we have 3xy, so that's correct. Now take the first factor, x is equal to minus y, or x equals minus 2y. Now we can substitute equation A. I will call this equation A and this equation B. So x will be minus y. So minus y in equation 1. See, minus y squared. And then 2, xy. 2 is minus y. Y minus y squared equals 1. See, this is all in equation 1. Simplify it on the next slide and see what you will get. So y squared, here y squared minus 2y squared, another minus y squared is equal to 1. Cancel out this y squared, minus 2y squared equals 1. Divide by minus 2. So y squared positive cannot be negative here. Complex solutions, not real. So this is rejected. Now go to equation B from the previous slide, which is minus 2y. Put it in the x here. So minus 2y squared, 2 minus 2y, y minus y squared. This is equation 1. When you simplify it, you get 4y squared minus 4y squared minus y squared equals 1. And then minus y squared is equal 1. When you multiply on both sides, you get y squared is equal negative. Also rejected. So no solution. When we have no solution at all, then we call the system inconsistent. Okay. See this one here? You can, if you like, see you can multiply with minus 1 also and add the equations again. So you'll get xy, y squared is equal number. Then you can get x in terms of y squared, but it'll be a little complicated when you go and substitute. That's why I said here, substitution will not work, elimination will not work. So sometimes these methods will give you very difficult steps. This is an easy way where you can factor the second equation. If you have a 0 in one of them, so this 0 will give you the little trick. All right, let's see now, question number 3. Solve the nonlinear system. 3x squared plus 2xy minus 5y squared is equal to 11. You see, also, we have another problem here. What can we do? We cannot substitute, we cannot eliminate, we cannot, what can we do? Take a second also, please. Think, put your ideas on a paper and see. Also, if you look here, you see the 11 on both sides, which is the same number. It can give us an idea that, how about canceling the 11, eliminating the 11? Let's see on the next slide what we'll do. So I have equation 1, equation 2. I will think, so the aim here is to eliminate the constant, 11 on the other side. So I multiply equation 2 by minus 1, it will be like this. Minus x squared minus 3xy minus y squared is equal minus 11. And this is equation 1 as it is. Let's add. So I get 2x squared minus xy minus 6y squared equals 0. Now I have an equation with 0, so I can factor it. See the idea? In the other system, question number 2, factoring is direct. Here you have to rearrange, you have to multiply with minus, you have to eliminate the constant, then you get an equation where it is equal to 0. So when you factor this, you get 2x plus 3y, just normal trinomial, multiplied by x minus 2y. So this is equal to 0, you see that one? So x will be minus 3y over 2. I will call this equation M. Second one, x equals 2y. I will call it equation V, just to have a little difference there. So I take equation M first, replace it in equation 2 there, here. It's a little easier. And then I will see what will happen. Then I will take equation x equals 2y, equation V. I will replace it again in equation 2, and we will see what will happen. You can try it yourself if you like. Let's see. So this is the system now because we need it. So from previous slide, I get equation M and equation V. So substitute equation M minus 3y over 2. This is the value for the x. You see here? Plus 3. X is minus 3y over 2 times the y. Plus y squared equals 11. Very nice. Now this one becomes 9y squared over 4. And this one becomes minus 9y squared over 2. And this is y squared, and this is 11. I mentioned in some other videos what to do when you have fractions. The best way is find the LCD for all fractions, which is 4 in this case, and multiply the last equation by 4. See, 4 here is black. Multiply by 4. So 9y squared. If you multiply by 4, 4 over 2 is 2. So this is 18y squared. 4y squared is equal to 44. Simplify the equation. This is minus 9y squared and the plus 4y squared. So this is minus. So y squared will be minus 44 over 5. Rejected. Because we cannot accept y squared positive equal negative on the other side. So let's continue on the next slide. What do we continue now? We take equation v and we replace it in equation 2. I think we will get some solutions. So let's substitute equation v, which is x is equal to y, easy, no fractions there, in equation 2. So I get 2y squared, 2y times y, plus y squared equals 11. Simplify the first part, the second part, the third part. So when you add, you get 11 here, see? 4, 6, and 1, 11 y squared is equal to 11. So y squared will be 1. Take the square root on both sides, y will be plus or minus 1. See now, if y equals 1, what will happen? If y equals minus 1, what will happen? So I go to v. See, go to v to find x. X will be 2 times y, x will be 2 times y. So we get x is 2. First, we put x always. 2, 1, minus 2, minus 1. You have to check proposed solution in the original system. Then the solution will be 2 points, 2, 1, minus 2, minus 1. I hope you enjoyed this one. Now let's look. So the first practice, we have x plus 1 squared, y minus 3 squared is equal to 4. X minus 3 squared, y plus 2 squared is equal to 2. Enjoy working with this atmosphere here. And then on the next practice, you can enjoy again with the green color, x squared minus 3xy plus y squared is equal to 4. X squared minus 5xy plus 6y squared is equal to 0. The answers only on the next slide. Thank you for watching this video, and I hope I will see you in another video very soon. Thank you very much.